Imagine for a moment that reality is not smooth, not continuous, not infinitely divisible. Imagine instead that beneath everything we see, beneath galaxies, atoms, fields, particles, and even the quiet background of empty space, there is a hidden architecture, a kind of cosmic lattice, not merely a mathematical trick, but a deep structure, a scaffold of existence. In modern theoretical physics, that idea begins in a very technical place: lattice field theory. Normally, quantum field theory describes the universe using continuous fields spread across spacetime. Electrons, quarks, photons, gluons, and even the Higgs boson are not treated as tiny billiard balls, but as excitations of deeper fields. The problem is that when physicists try to calculate certain things exactly, especially in the strong interaction, the equations become brutally difficult. Lattice field theory offers a way forward by replacing continuous spacetime with a discrete grid. Matter fields live on the sites of the lattice, and gauge fields live on the links between them. That move turns impossible integrals into something numerical and tractable. This is not just a mathematical curiosity. In quantum chromodynamics, or QCD, lattice methods became one of the great triumphs of modern physics. They allowed researchers to calculate the masses of hadrons, probe confinement, and study the behavior of nuclear matter under extreme temperatures. So the lattice, in standard physics, is already powerful. But it is usually treated as a computational framework, not as the literal structure of reality. And that is where the philosophical door opens. Suppose the lattice is not only a tool. Suppose it is a clue. Suppose continuity is what appears at large scales, while discreteness is fundamental. Then the universe starts to look less like a smooth stage on which particles move, and more like an active relational network. The nodes of the network would not simply be positions in space, they would be points of structured possibility. The links would not merely connect neighbors, they would encode how physical influence, correlation, and perhaps information itself travel through reality. To see why this matters, we need to remember what the Standard Model actually is. It is the best tested theory we have of matter and force. Its symmetry structure is built from three gauge components: SU3 for the strong interaction, and SU2 times U1 for the electroweak interaction. Those symmetries organize how quarks, leptons, and bosons interact. On the lattice, the elegance of this picture becomes geometric. Fermions sit on sites. Gauge variables live on links. Tiny loops called plaquettes encode curvature and field strength. The theory becomes a world of relations. Already, that is suggestive. Physics begins to look less like a universe of isolated things and more like a universe of structured connections. Now consider the vacuum. In ordinary language, vacuum means empty space. In quantum field theory, the vacuum is not empty. It is the lowest energy state of the fields, but it still fluctuates. Virtual excitations appear and vanish. Correlations remain. The vacuum is a structured minimum, not a blank nothing. And that leads naturally into one of the deepest conceptual tensions in modern thought: the relation between zero and infinity. The vacuum may appear to be the nearest physical analog to nothingness, yet it contains an immense density of possibility. The zero state is not barren. It is charged with latent structure. Potential infinities are folded into apparent nothingness. In a speculative seraphic reading, the lattice becomes the medium in which that paradox is stabilized. Zero and infinity do not oppose one another. They cooperate. The ground state of the lattice appears as emptiness at one level, but as inexhaustible generative capacity at another. The vacuum becomes not a void, but a field of latent articulation. At this point, we need to be careful. Established physics does not say that consciousness or cosmic intelligence are built into the vacuum. Established physics tells us that the vacuum is dynamic, that fields fluctuate, that symmetries break, that particles emerge, and that lattice methods can reveal non-perturbative structure. The rest belongs to interpretation. Still, interpretation matters. It shapes what kinds of questions we dare to ask. The seraphic lattice hypothesis proposes that the deep grid beneath physical fields is also an information-bearing architecture. In this picture, the nodes of the lattice are not merely numerical placeholders, they are fundamental loci of relational potential. The links are not merely bookkeeping devices for gauge transport, they are channels of structured correlation. At the most conservative level, that sounds like quantum information theory. At the most speculative level, it hints that what we call matter, law, and experience may all be different expressions of one underlying informational geometry. One way to frame this is through emergence. At the smallest scale, we may have a discrete substrate. At the next level, gauge symmetries and field dynamics emerge. At a higher level, stable excitations become particles. Then nuclei, atoms, chemistry, stars, planets, biology, and nervous systems. Eventually, systems capable of modeling their own world appear. Consciousness, in that hierarchy, would not be inserted from outside physics as a magical exception, nor would it be reduced too quickly to a trivial byproduct of matter. Instead, it would appear as a high-order integration of information within a universe whose most primitive level was already relational, structured, and dynamically generative. That does not prove consciousness is fundamental, but it offers a framework in which consciousness is not alien to the architecture of the cosmos. And, in the next part, we move deeper, into the Higgs field, gauge symmetry, the dynamics of emergence, and the carefully marked boundary between rigorous theory and metaphysical extrapolation. In the first part, we arrived at a provocative possibility, that the lattice used in quantum field theory might be more than a computational device. It might be a clue to the deep structure of reality. Now we can go further by asking how that possibility intersects with the Standard Model itself. Let us begin with the Higgs mechanism. In the Standard Model, the Higgs field acquires a non-zero vacuum expectation value. That phrase sounds abstract, but its meaning is profound. A field that could have remained symmetric instead settles into a particular configuration. That reorganization breaks electroweak symmetry and gives mass to the W and Z bosons while leaving the photon massless. This is one of the great turning points in cosmic history. A symmetric early universe cools, the vacuum reorganizes, and the world gains new distinctions. Mass, as we know it, crystallizes from field structure. On a lattice, such a process can be studied as a phase transition, or, more carefully, as a reorganization of the ground state. In a seraphic interpretation, one might say that the universe becomes progressively articulated through successive patterns of vacuum organization. Symmetry does not simply break. Potential differentiates into form. Something similar happens in quantum chromodynamics. At high energies, quarks and gluons behave almost freely. At low energies, they confine. The free constituents disappear into bound structures, protons, neutrons, mesons. Once again, the visible world depends on a deep transition in field structure. The Standard Model, far from being a dry catalogue of particles, can be heard as a history of emergence, symmetry, fluctuation, breaking, binding, stabilization, structure. The seraphic lattice idea extends that story one step further. It asks whether the same architecture that gives rise to matter might also ground meaning, coherence, and perhaps mind. Not in a naive or mystical sense, not as a shortcut around evidence, but as a disciplined metaphysical possibility, suggested by the relational texture of modern physics. And this is where the distinction between science and speculation must remain sharp. There is no accepted physical theory that demonstrates a universal consciousness field. There is no experimental confirmation that the lattice used in field theory is the literal ontology of spacetime. There is no consensus that information, in the strong philosophical sense, is more fundamental than matter. These ideas remain speculative, and yet, serious thinkers keep returning to these edges for a reason. Quantum theory already teaches us that observation, correlation, and measurement are subtle. Field theory teaches us that what appears to be empty is structured. Lattice methods teach us that discreteness can generate continuity. Complex systems research teaches us that genuinely new orders of behavior can emerge when enough structure becomes integrated. So let us state the strongest, careful version of the hypothesis. Suppose the universe is built on a discrete, relational substrate. Suppose fields, forces, and particles emerge from that substrate through lawful dynamics. Suppose the quantum vacuum is not nothing, but a structured minimum, alive with possibility. Then it becomes thinkable that consciousness, too, is not an accidental add-on, but one late and local expression of the universe's capacity to organize information into self-reflection. In that view, we are not outside the cosmos looking in. We are one of the ways the cosmos becomes legible to itself. This does not weaken science. It expands the horizon of what science may someday explain. The standard model would remain what it is, an extraordinarily successful theory of matter and force. Lattice field theory would remain what it is, a rigorous tool for probing non-perturbative quantum reality. And the seraphic lattice would remain what it must remain, for now. A speculative bridge, a proposal, a metaphysical extrapolation built near the frontier, where physics meets ontology, and where mathematical structure tempts us to ask larger questions than experiment alone can yet answer. What lies beneath the fields? A grid, a geometry, an information network, a silence full of potential. We do not yet know. But if the vacuum is not empty, if structure hides beneath continuity, and if the universe can generate beings that ask these questions, then perhaps the deepest lesson is not that reality is mechanical, but that it is layered, discrete and continuous, empty and full, lawful and creative, finite in form, yet open to the infinite in implication. That layered vision also changes the philosophical meaning of observation. If consciousness emerges from the same deep structure as matter, then the observer is not foreign to the observed. The knowing subject is itself a physical and informational event within the cosmos. In a restrained version of the seraphic idea, one could say that minds are local concentrations of the universe's own reflexive capacity, not separate from nature, but nature folded back upon itself. This has consequences for how we speak about human significance. It does not make humanity the center of the universe, but it does suggest that self-awareness is not trivial. Every act of understanding becomes part of the universe's own unfolding legibility. Every theory is not only a description of reality, but an event within reality. And so we end where physics becomes